G'day everyone, Andrew Price here with another Blender Guru tutorial. This is part 2 of the PBR metal series. Part 1 we covered dielectrics, so basically everything non-metal, ceramic, plastic, most things. And then in this video, part 2, we're going to be doing metal. So there is a little bit of crossover, which is why if you haven't watched part 1, you should go ahead and click on the left-hand side of your screen right now and go and watch it. But otherwise, we're going to continue on with metal. So metal, of course, is used a lot in CG, whether it be from just creating some weapons, some gadgets, making some characters with organic features as well as, metallic things and plating. Sci-fi, of course, lots of gadgetry and spaceships, as well as environments. Point being is that metal is just about everywhere. Even if it's not, an area that maybe you're not making a robot, it is going to be somewhere in your scene at least some point in the future. And the more realistic you can make it, the better your overall render is going to look, essentially. So there are two ways of making metal. The first method is the one I like to call the I'll wing it metal, which is, funnily enough, how I've been making metal for most of my life, which is to really approach it the way that you approach most materials in Blender, which is like, you have a stab at it. Diffuse, give a little bit of color, give some shininess, and then you go for it. Doesn't result in anything good. What we're going to do in this tutorial is create a PBR, correct, physically based rendering, correct metal. And we're going to do a bunch of stuff in the node editor. I'll walk you through it. But we're going to put it all inside one neat little node group that you can see right there. So that's what this video is going to be all about. PBR metal, realistic metal for better renders. So there is a bit to go over in this video, so I'll just give you a quick overview of each part. We're going to start with the theory. Some of the reasons why metal is different to a standard dielectric material. So some of the physics involved in that. Then the walkthrough process on how to make your own PBR metal material. And then to finish it off as a minor thing, I'll show you how to combine both the dielectric tutorial node group as well as this metal node group into one little metal shader. But the main point of this video is to give you that one nice little neat metal node group there. By the way, if you want to jump ahead, you can click on any of these titles here. I've got the annotations linked up as chapter marks. So feel free to jump ahead if you're not interested in any of the theory. Okay, so the theory of metal is basically summed up as follows. These are the 5 simple rules. These are really the main differences between a dielectric material and a metal material. And we're going to discuss them all in detail right now. Starting with number 1, metal is 100% gloss. That is right. Now, when I first heard this, I was like, come on. It can't be 100% gloss because I can see the diffuse. Now, that's not true. You can't see a diffuse. A diffuse shader on a metal material, on a pure metal material, is a physical impossibility. Now, I think I started hearing about this maybe a year ago when maybe some of the PBR stuff started making its way out on the internet, and somebody was mentioning how you should never use a diffuse shader for metal. And I thought that's crazy. I always use a diffuse shader. That's wrong. I've been doing it this way for ages. And then I was at the Gnomon workshop in Melbourne. They had the first one here in Australia. And they had the CGI supervisor from Star Wars The Force Awakens there. And he was like, there's no way that a diffuse shader should ever be in metal. It's a physical impossibility. It cannot happen. And I was like, maybe there's more to this. So I started reading up on it, and it turns out it's absolutely true. If you're making metal, and this is probably the biggest mistake that most people make when they're making metal, is they mix it with a diffuse shader, because that's how most things have diffuse, but metal does not. Now, to understand that, because I know this can be a little bit hard to grasp, because you're looking at this and you're going like, come on, man, I can see the diffuse there. I'll explain some of the physics. Now, if you're not interested in this, you just forget all of this, but it does help to know it, to sort of understand it. So when we're talking about non-metals, which is dielectric, so anything non-metal, this is how it works in the real world. Now, this is like microscopic view, okay? So we're sort of like zooming in like tiny millimeters here. This is what's happening with surfaces. Everything around you right now, you look around your office, your room, this is what's happening to the surfaces. The light, which is this yellow beam here, is hitting the surface, and two things are happening. Some of the light is reflecting off it, which is what we call the specular reflection. And depending on how rough the surface is, the wider these rays will be. Doesn't matter. So some of it is reflection. The other bit is what's called refraction. And this is light rays that actually go beneath the surface. Now, this is what sort of, it was hard for me to understand this at first, because when you think about 3D, you think about just like there's a hard surface, some of the light bounces off it or it colors it. But in the real world, it's far more complex than that. Like what we do in 3D is kind of an approximation of it. But what's really happening in the real world is that every surface is thick, right? Like you can imagine this here is like zoomed in like a millimeter of like a vase, like a ceramic vase, right? Some of the light rays are going into the surface. And what's happening is, so that's called a refraction. Some of them are getting absorbed, which means that they're disappearing, and some of them are getting scattered. So that's these little green arrows coming out here, and then some of them are making their way out of the surface. And that there, the ones that make its way out, that's actually what you see when you see diffuse. So everything in the diffuse channel is made up of that. The refraction and the scattering of the light. That's the diffuse. Okay, so this is a standard non-metal. This is how all non-metals work. Metals, on the other hand, they reflect light like normal, but all of the other light is absorbed into it. It does not escape the metal. At least if I am to assume that this paper here from Segraph is correct, which I believe it is. Now, anytime you mention this, like you get way too technical. Some people will stress the exceptions. So like some people say that some metal can have like 1% diffuse, like a tiny amount. Like they say that it's near or non-negligible, like you can barely see it. And that's probably true. Maybe some little tiny bits get out. And other people say that you can't really lump materials into two groups as non-metal and metal, because in the real world, they're variations of it. It's it's a grayscale spectrum, and you've got some which are nearer to non-metal and some which are nearer to metal. They're not a hard line. There's even a Wikipedia article on the line between non-metals and metals. You can have a look at it if you want. Honestly, if you get way too into that, you just give up. Like, the whole point of this is to try to make this work for most materials. If you want to make some rare earth mineral that's just slightly on the edge of non-metal and metals, go for it. You can break the laws of physics and go for like that little thing, whatever you want to do. But for most things, that's what this series is about. Dielectrics was part 1, the basic rules for most dielectric things. This is metal, so we are just going to be using 100% gloss and sticking with it. So there you go. All right, let's go ahead and move on now. Getting a little deep there. To the second interesting thing with PBR metals, and that is that they have colored reflections. So you may have heard, and you probably know, that when you're making making any material in cycles, you should never give a color to the glossy shader. And that is correct. You should never do that for a dielectric material, because all of the light that bounces off it, I think they're equal wavelengths, like the R, G, and the B. RGB, I don't know. Whereas metal, I believe some of them are, they come out funny. Like some of them, there's less of a wavelength, which is why you get a tinted reflection. So metals are the only thing that can have a colored reflection. So for example, gold, of course, it's the most one most people know of. Copper, a few other ones like that. Most of them are still grayscale, but a few of them, yeah, have different ones. So that's another interesting point, and we'll get more into this colored stuff when we get into Blender. Number 3, everything still has Fresnel. So you might remember in the first dielectric part 1 video I mentioned, I kept repeating, everything has Fresnel, everything has Fresnel. Metal is no exception. It still has Fresnel. Now, when I first heard of this, I thought, Well, that's weird because, I mean, metal is already 100% reflective. So Fresnel is just, it's reflection. So what difference would it make if you've got reflection on reflection? But what's actually happening is that if you look at these values here, so some of the light, a metal is not a mirror, okay? So it's not just 100% bouncing light off it again. Some of the light is getting absorbed into it. So that's this refracted light. Some of it's getting absorbed into it. So it just means that the metal as a whole will always be darker than the light that it's hitting, always. So I think most are, I read like between 60% and 90% reflective, most metals, which is what these values here are. So when you darken it, when you make the color less and less, it's like it's making it so that it absorbs more of the light that's reflecting. Anyway, a little bit technical. The point being is that Fresnel will sit on top of that and will increase the reflection to be more than the base metal color. This will make a lot more sense when we get into Blender. So if this is going over your head right now, don't worry. It'll make sense in a moment. The other interesting point, number 4 of the 5 simple rules, is that it has varied index of refraction. So most dielectric materials have an index, the IOR value, of 1.45, okay, for most materials. Now this is like when you use the Fresnel node, you've got that little value there and you can increase it, decrease it, and it sort of changes the edge look of it or whatever. That's what we're talking about here. Now, yeah, most dielectrics are at 1.45 and you shouldn't really have to change it much. Metals, however, are all over the shop. You can see here, they're just crazy amounts. Now, here's the thing. I know some people will disagree with me on this, but I think caring about index of refraction is a waste of time. If you're making materials and you're like honestly Googling, like what's the value of chromium for this leg of a chair so that I can make sure it's accurate, no one's going to notice that. Like this is wasted time that you should be spending on the rest of the art piece that you're making. This value here is going to make such an infinitesimally small impact on the material. It's really not worth thinking about because all this is controlling is this, the Fresnel on the edge of it. And it's already 100% reflective, a tinted reflection, 100% reflective. It's just that slight little bit. And it's already like so hard to see just with this little bit here. Like changing this is not going to alter much. The other thing, by the way, is you'll notice these have values of less than 1, which if you put it into Blender, does something very weird. It inverts the Fresnel because apparently that was designed for surfaces meeting. Very technical, like if you've got water and you've got glass, if you set it to negative IOR, it looks correct. Yeah. Anyway, you shouldn't use that. You should never use a value less than 1 because basically the index of refraction is the speed at which light can go through the surface. So 1 stands for a vacuum, which is air, almost air. Which is, yeah, it's going normal speed, right? 1. Everything else, like the 1.45 for dielectrics, whatever, it's just slowing down a little bit, okay? If you're going negative, that would mean that the light is speeding up. So I don't get it. If you look at like index of refraction values online, they've got values under 1, and it's weird. You should never use it. And honestly, I think just keep it at 1.45. It's such a small thing. Like I said, don't worry about index of refraction. You can if you want to. I say just forget about it. Yeah, really, the main thing that matters is that you've got 100% gloss, you've got colored reflection, you've got a little bit of Fresnel. Don't worry about the IOR, all right? The final one that is different to dielectrics is that, as well as Fresnel, the edge of the metal can change in color very, very slightly. So this is called an edge tint. And this is, again, it's one of those real world things, but it's so hard to actually find photos of it or like to see it in the real world. I tried to look online, try and get some photos, and it's really hard because it's such a tiny, small thing. So this is actually a paper that someone wrote about this, and these are the values here. So it's like the color of gold, like if you're looking at it front on, is that, and then at the edge, it will slightly become a lighter version of that color, almost. Which is kind of almost a Fresnel effect, but it's a little bit different to that. Anyway, the point being is I personally like to use this as a creative tool, and I'll show you when we get into Blender. But these values here, again, you can Google them if you want to, but Why? Just have fun with it. You can make them any color you want, and it just looks so cool. And I'll show you. Anyways, so that's some of the theory. Okay. There's a lot there, and honestly, if you can delve deeper and deeper into it. One of the guys I saw on a forum, he said something which is pretty true, which is like, when it comes to PBR, don't overthink it. Just try and keep it as simple as possible, because you will eventually give up if you try and get too technical. So these are just some basic rules to remember. But now we can go ahead and jump into Blender essentially. So, one final thing. This is the exceptions, okay? Because everything I've mentioned there applies to metals, raw metals. However, most metals have some form of dirt, rust, oxidation, or paint on top of it. So if it's coated in something, if you've got like chipped paint, you've got a jerry can and it's got paint on it, and then you've got rusted metal underneath it, and then you've maybe got some raw metal underneath it. The only thing that's really metal that's going to have everything we just talked about is the tiny little bit of metal. The paint, that's a dielectric material. The rust, that's also, I believe, technically a dielectric as well, because it definitely has diffuse, that's for sure. So that's the thing, like most metal that you see will look like sort of like the one on the right there. And it's got dirt on it. It's got like from rain and weathering effects. It's got like some slime that's sort of fallen onto it. That's all dielectric. It's not like anything that touches metal is now bound by these rules. So you still treat the layers of, you got the base layer here, you've got the smudges and the dirt on top, you've got the paint on top, whatever, you treat those materials as separate things. All we're talking about with all these rules here is the base raw metal. So there you go. All right, let's go ahead now. Let's do it in Blender. So jump over to Blender now, open it up. Okay, so here we are with the file that we finished with at the end of part 1. So we've just got a dielectric material here and a less, more slider, whatever. The reason we're reusing it is that we are going to repurpose some of the stuff from inside this dielectric node group we've created. So that's why just reopen it and we can continue on from there. But we are making a new material, so go ahead and remove that material and add a new one. You can go ahead and call it metal if you want. So first things first, no diffuse. We don't need to go over that again. We are using 100% a glossy shader. And that's it right there. Now, this color value here defines both, for like colored metal, like gold, which we spoke about, but also the brightness of the metal. So you remember these values here. So some of them are really bright. So like silver, for example, is a very bright metal. So to do that, it would just be something, I think it's like about that. Maybe it's a little bit more, but it's a very bright metal. Whereas others, even though they don't have a color, like say iron, it's a lot lower, like down to about here. So that's really like one of the bigger differences, I guess, is that if you wanted to stay accurate, it probably helps to at least have a base understanding of which metals have which sort of brightness. So most metals, as I mentioned, are between the 60 to 90% range. So as a basic rule, don't ever go 100% there, like just make it 100% white, and don't ever go too dark as well, because then it doesn't really look much like metal. But if you wanted to get the exact values for metal, you can actually get them online from this document here, the Physically Based Rendering Encyclopedia. Now, I can't actually put an annotation link to this because it's not my website, but if you just Google Physically Based Rendering Encyclopedia, you will find it. And this is a document that one 3D artist put together, Brian Yu, as a reference guide for everybody else to use. So he researched a whole bunch of stuff with different sources and everything, and then he just put it into one neat guide, because it is actually hard to find good information out there related to this stuff. So he just combined it all into one neat article. It's really, really cool. These are the people that are looking at it right now, which is, it's quite a popular article, even though he wrote it 2014, I think. Anyways, down here, underneath the measured base color for metals, he's actually got the RGB values for different metals. There's other places you can get them online as well, but it's handy to have them here. So how you would use this, for example, like let's say you want gold. So it's 17633. So I would go 1.776, and then I think it's 0.336. And that's it. That's gold. So that's the exact value for gold. Now, one thing you like, again, that's just the starting step. So it's kind of important to have like, like the base brightness, right? But from there on, you can tweak it if you want. Like if it's too bright, you can turn it down a little bit. You don't have to be locked into this. I don't want to restrict your creativity. But one thing that can help is if you make a node group with just these values. So you don't have to Google every time you want to create something and go like, oh, what's iron? So what I did, and you can do this as well, is you can make a node group. If you just go RGB, and you can just add in any of these values here. So let's say we're going to make the iron one, which is so it's 0.56, 0.57, 0.58. This is completely optional. You don't have to do this. Then if I hit Control G, I've now made a node group out of this. So then if I call this output there iron, then I know that that one is iron. And then if I want to make the one underneath it, I would be silver, which is 0.97. It's a little bit brighter, 0.972. What's the other one? It's 5758. Oh, it's already, wait a minute. No, that's not right. 96915, okay. 96915. Okay, and then I would just drag that in there, and then that is my silver color. Okay, pretty basic. I'm sure you get the idea of it. So anyway, one final thing, I guess I'll just make the one for the gold as well, which was, what was it? It was 1.776, was it? No, 776, whatever, and 0.33. And there we go. Okay, so that's our gold right there. So then it's like in the future when you're creating something and you got a number of stuff, you can bring in this node group. So if you give it a proper name like metal color, then next time you're making another group, you can just go like, oh, bring in my metal color. And I just drag that into there. And now I've got iron, and then I've got silver, and then I've got gold like that. So you can do that for all of them if you want. It's completely up to you. In any case, so there we go. So that's basically it. So you just want to try and get the coloring basically right. So it's like metal. The next thing is Fresnel. So everything has Fresnel. So you'll remember that I originally got confused with Fresnel because my understanding of Fresnel was that it affects the reflection, but it's glossy, right? So how is it making reflection more if it's already 100% reflective? And it's because the reflection is really powered by this value here. The darker you make this, it means that the more of the light is being absorbed into this and less is being output as reflective. So if you made this really dark like this, and then if you give it a bright edge, it's going to make that edge more reflective. So that's what we're doing. So what you want to do is you want to reuse your Fresnel node. If you are using the same blend file that you created from part one, you should already have it. Just go to Group, and you'll see it there, Fresnel. Okay. Now the reason that we're using this Fresnel node group over the base Fresnel, which comes with Blender, just to recap from part one, is that while this is fine, it's not influenced by the roughness of the material. So with our one here, you can see that as the roughness goes up, the Fresnel drops off, which is how it is in the real world. So that's why we're reusing it. So what we want to do is right in between here and here, we want to add in a mix RGB node right here. And we're going to take the output from our factor of our Fresnel right there and put that into the factor input of this mix node. And what that's going to do is it's going to, using that grayscale white and black, it's going to make the top input the black value and the bottom input the white value. So now with this gold going in there like that, so you could see like, yeah, if I make this like green or like hot pink or whatever, you can see the effect that it's having on our gold right there, on our, well, that's just color. How it's having it, how it looks right there, right? Now, if I make this, instead of it being a funky color, if I just make it a solid white color, you can see what it's doing. It's making it more reflective than the rest. So when I use that with my gold, let's just give it a real example. There you go. Now you can see this is really, really subtle. So this is how it looks with the Fresnel, and this is how it looks without it, okay? Not much difference because we are dealing with, after all, it's already 100% reflective. So it's just adding that extra little boost of reflection right on the edge there. Now you can see like it's almost not even worth doing. And for the index of refraction, I really think it's not worth doing. Like if you increase this to 2, that's all it's doing is it's just changing that very, very slightly right there. Like if I make that 2, if I make it 3, 1.45, it just changes it just a little bit. That's why I say it's barely, like you can barely see any change you make to the index of refraction. So if you want to, you can, Google the exact values for metals and put them in here. I think it's a waste of, oh, actually, hang on a second. This isn't even connected to the Fresnel node like it should. Okay, so it will actually be a little bit more than I just demonstrated there. 1.45. So as you increase it, it's like bleeding out the edge just a little bit further. Yeah. And for different metals, it'll be higher or lower or whatever. But I really do think it is a waste of time. And this is the other thing with Fresnel, and this is what we have to change right now, is that you can see in the center there, let's hit this at the default, 1.45, because I just leave it at that for metal. You can see that the center there is this grayish color, which is like, and that we use that gray color, and that's why the base Fresnel works like that. It gives you that gray color there, because every dielectric material has some reflection in the middle there, which it calculates based off this index of refraction. So that is like 3.34%. You don't need to know this, just telling you. But for metal, we don't need that. We don't need that, like we don't need extra white in the center of the metal. So what we're going to do here is we're going to do something to just extract that gray out of it and just make it solid black. Because right now what this is doing is, as it's powering through this, is it's slightly making this part in the center there white as well, which we don't want. We actually just want it to be the base, the base metal color that we give it. We don't want it to be tainted by white, even just a little bit. It's not really, not really needed. So what we're going to do is I'm going to, in our Fresnel node right here, I'm going to duplicate the Fresnel node that's already included in it, and I'm going to take the incoming from our geometry one right there, which if you remember from part 1, what it does is, let me just look at that. So this is how the Fresnel node looks normally. You can see the gray value in the center there. If we just have a look at the incoming, it's treating the entire Fresnel as if we are looking at it dead on in the center. So it's essentially, it's the exact gray color that's from the center there without any of the white. So what that means is if we do a math equation, and again, this is a little cheat that I learned from Cinecat Pro, if we drop the 2 together in the same math node and then set it to subtract, it's subtracting that gray value from our base Fresnel, which means it just becomes solid black. And that's really cool. So that's really what we want for it. So it's a small thing. It just gets rid of the, little 3.3% reflectivity. But since it's not needed for metal, that's why we're doing this thing. But here's the thing. If we reused it, like if we actually did this for this, then our dielectric material, which you'll remember, is actually using that value right there. So it would actually change our dielectric material, which, if you're making both of them in the same blend file, that's going to be annoying. So what you want to do instead is actually just make a separate output right here and put that in there. So we're going to call this bottom one, I'm going to call this metal Fresnel. And the top one, I'll just take, let me move this across there. It's getting a little hard to squint at a tiny percentage of your screen. So this, I'm going to just take this Fresnel, so like the one that it was just before we started tinkering in here, and put that into the top input. And then this one I'll just call dielectric Fresnel. Okay, there we go. So now I just want to make sure that I'm using the bottom one. So that's the difference between the two of them right there. So the dielectric one you use for dielectric, bottom one you use for metal. Okay, very small, doesn't really make much of a difference, but we did it anyway. It's never a good thing when you're following a tutorial and they're like, yeah, we didn't really need to do this, but we're going to do it anyway. I don't know. Yeah. Especially if you're going to increase the index of refraction later on. Like you can see now, yeah, and that's really why I did it, because I know some people will want to use the exact index of refraction, and I think if you do it incorrectly, like if we look at that one, it'll be a slightly different sort of look. Yeah, anyway, really small either way. Okay, all right. Let's go ahead and move on with the edge tint. So you remember from our presentation I showed you before that metals have a slightly discoloration towards the edge of the material there. And I'll show you the slide again just so you can see what those colors look like, it's like this. So that's the base color, that orange color, which is what we would be using for our gold right there. The edge tint is just going to be a slightly yellower color for the gold. So how we're going to do that is we're going to create another one of these mix RGB nodes and drop it in between it again. And then I'm going to put something into this factor input there to just add like a second Fresnel, essentially. So I'm going to use the Fresnel node again, and I'm going to put it down here. And again, this comes from Cinecat Pro. He taught this one. Really cool idea. This is to use a layer weight node. So layer weights and Fresnels, they look very similar. Like if I just drag this into here, and I'll just have a look at that. That's correct, is that? Yeah. Okay, so this is the layer weight node right here. You can see it looks very similar to the Fresnel. There are a couple of differences between the layer weight node and the Fresnel node. One of them is that it works on both sides of the face, unlike Fresnel, which it'll only work on one side of the face. Very small thing. And the other thing is that instead of it being an index of refraction, it's just a value from 0 to 1. So some artists actually just prefer to use this layer weight node instead of the Fresnel because they really don't want to be bogged down with the science stuff. They just want to like have fun with it or whatever. Oh, I forgot as well. Make sure your index of refraction is in your bottom Fresnel there as well. That would probably influence this, I guess, a little bit. Yeah, make it less impacted by the index. So some artists prefer to use this layer weight just because, yeah, it's more intuitive to an artist sort of workflow. It's just like controlling that. So we're going to use it here to influence the edge tint. So, oh, and you want to use the facing value. Yeah, sorry. That was actually just the Fresnel, wasn't it? Okay, so this is the facing value like that. Now, here's the thing with this facing value. You can see that from 0 to 1, it's just like bam, like that's the facing value. Like there's not really much of a change off there. And I think this is the same problem that happens with what we spoke about in part 1 with the roughness slider. How it's not, apparently it's like it's converting one number to the wrong number incorrectly. So essentially all you need to do is add in a math node, set it to power, and then set that value to 2. And now it's going to be a lot more intuitive. So now it's like from 0 to 0.1, like it's slightly increasing it. So it's doing what we did for the glossy roughness slider as well. And if you go all the way to 1, it's like it's making the entire thing white. But anyways, most of the time you just want to keep it around about 0.5. But anyway, I won't explain too much because I'm sure it's confusing a lot of you already. All we want to do is we want to drop this into that bottom input down there. So creating a new input, new output. And I'm just going to call this one rim. And I'll make sure I connect that dielectric one properly like it should be. And now we can see it right there. Now here's the thing. Actually, no, we'll do that in a second. First of all, let's just connect it to our mix node down here. So I'm going to drop that into the factor input down there. And now I can make this color here anything I want the edge color to be. Like that. So what we've done here with this little weird setup is we're using, at the start, we've got the gold color, which is this. Then we're giving it some edge tint, which we can make any color we want, like a little orangey color like that. Then we're putting Fresnel on top of that. So like some of it is orange, but the Fresnel is less than that. So the very edge of it is going to be slightly more reflective than the rest of it. And then we've got all that feeding into a glossy shader like that. So yeah, it's a little weird, but once you've done it once, you really don't have to think about it again. But here's what I like to do with this rim light here. Honestly, you can use the accurate values if you wanted to, but they're very hard to find online. I tried looking. This is the best thing I could find. Honestly, it's just the original color, but slightly brighter. Like it's basically a Fresnel almost. But what I like to do instead is I like to change it up. I like to use different colors. So for gold, I might go for like a reddish color, like that. And then to have even more creative control over it, I like to expose this blend value here, because remember that the blend is controlling how much of that edge tint. So if you go all the way to 1, it's really strong. So what I like to do is just take that, put that into the bottom input down there, and then I call this rim effect. Give it a default value of 0.7. And there we go. So now outside here, as I'm working on a material, it's like, oh, I want more or less of this. And then I can change this color here to be whatever I want. A little bit blue maybe. Anyway, there you go. So now we've done everything. We've got everything we need to, but it's all spread out. It's all very messy. So what we want to do is make one nice, neat node group out of everything here. So I'm going to just select these 4 nodes here. We don't need this metal color. That's sort of a separate optional thing. So these 4 right here, and I'm going to hit Control G. It brought it in anyway. So get rid of that guy. Let me get a drink of my tea here. My goodness. It's the 3rd time I've recorded this part of the tutorial because the other 2 times I just get mixed up, start explaining the wrong thing, start feeling unqualified. Anyway, so now we've put it into one node group. Now we need to expose the values that we want to have control over. So what we're going to do is basically just drag the values out here and to create the new input that would appear out here. So the first one that I've dragged out, that ugly green color, is going to be the metal. We'll call it the base color. Base color, like that. And you can give it the default value of something a little bit more appropriate. Maybe a grayish color like that. This bottom one underneath it, that is going to be called the rim color. And again, you can give it a more appropriate value, maybe slightly a little bit blue, something like that. The Fresnel, we don't want to drag that value out because the Fresnel is always white. That's just what it always is, because that's what it's this effect. So we do want to control if you wanted to, you could control the index of refraction. I actually personally, I don't think it's that necessary. I think just leave it at the default 1.45 or whatever it is. It's very tiny. I said that already. The one I do want though is roughness. So I want the roughness of our Fresnel to affect both the Fresnel as well as the roughness of the glossy shader down there. So it's given it a value of 0, but that's all right. Okay, so now as I increase the roughness, it's gonna decrease the amount of Fresnel on the, actually, let's just change these colors, my goodness. It's looking psychedelic here. Bring back my little metal colors. Oh, come on. Drag that in there. And then I'll make this a little bit easier on the eyes. There we go, and I'll turn down my roughness. Okay, cool. And before I forget it, the same thing as what I mentioned in part 1 about the roughness values in Blender being incorrect, it's true here as well. So what we need to do is add in a math node and drop it between your roughness. So wherever roughness is being connected, so right there, drop that down there, and then set this to the power of 2, okay? All that's doing is it's just fixing, really, it's kind of fixing a bug in Blender. I'm hesitant to say bug because I'm sure someone will explain to me why the roughness behaves the way it actually does, but putting it through the power of 2 actually makes the roughness proper, so that when you increase it from 0 to 0.1, it doesn't suddenly go like really blurry and then doesn't affect the rest. So now it's a little bit more smoother and behaves like it should. Anyways, just did that so we don't forget it. And then the other one, we don't have a reflection amount because it's solidly 100% reflective, but we do have a normal amount, which is going to be the bumpiness of the material, and you want that to affect the Fresnel as well as your glossy shader. So put that in there as well. Now the other one I like to expose, this is up to you, but I like to expose the rim effect so that on the outside of it, I can decide how much of that rim color I want to show through. Okay, so that's just me. It's totally up to you what you actually do with it. But there you go. We now have a nice looking metal color. A nice looking metal node here, which is very easy to piece together a nice looking material. Now, you might be looking at this and you're thinking like, oh, that's cool, man. But look, I want to actually make a metal that looks nice, that actually looks like real metal, and I can't do that without a diffuse shader. Like, it was a big thing for me as well. When I started doing this method, it's like, I don't know how to make it look like metal anymore. So for starters, most of the diffuse color that you're probably thinking of is really roughness. So if you want to think roughness, like, more diffuse, you can increase your roughness. It's going to start to look more diffuse. Like, look at that. It's kind of diffuse-ish. The other one is you can decrease the amount of your base color there. So if it is looking too bright as a metal, then you can just increase this value here until it starts to look a little bit more appropriate. This HDR sort of makes everything really bright on the edges, just because it's a weird looking HDR that I've got. Actually, I might change that just so that we've actually got a more, I mean, it was all right for the rest of it, but maybe this stuff. Shout out to Greg Zoll's HDR pack. It's pretty cool. He's given me his pack here to work with, as well as some of my own skies and various odd bits. But these are just one. I honestly just use this stuff for testing out materials, just so that I can see how things are looking in a more natural looking lighting environment. Anyways, back to our material here. So what I'll show you very quickly is how to make this metal look like metal the way it should be. So if we've got this correct here, I'm trying to, hang on a second here. Let's actually make this gold. Let's just make this gold right now. So I'm just going to use a little bit orangish color on the edge there, like so. Okay, so this is our gold right now. That's what's going on. I'll turn down the rim effect because it's a little too heavy. There we go. Now let's actually turn this into a scratched gold look. So the way I'm going to do this is by using textures that you should use for this. So normally when people think metal, they think of like going on CG Textures or textures.com and downloading a metal texture and then using that in a diffuse thing. And that's just completely wrong. What you want to do instead is start with a completely nice looking shader like this, the metallic shader, and then you apply that weathering and scratching effect to this shader. So the way we're going to do that is by using textures from Polygon. Polygon.com, my own site. So here we've actually, because they're so hard to find online, we actually created them. So these are some scratch maps, which are just scratches. They don't have a diffuse color or anything underneath it. It's just scratches. And the good thing is that as well as black and white maps, so we've got black and white maps, the inverted maps, as well as a normal map. So that's the important one, because with that normal map, you can use it to impact the bump, the physical bumpness of that material. So you can go ahead and download that or any number of you can experiment, try some different ones. I also like to use the smudges, so like wiping residue and things like that, dirt or fingerprints that might appear on top of it. Actually, let's use that. Let's try one of these. So I'll just download this overlay right here at 6K. All right. And now I will go to Blender and let's start using it. So first of all, we add in an image texture right here. And then I'm going to use one of these scratches. Let's just try this one right here. Load this in. And this is a normal map. It's that purple looking normal map. So I'm going to feed this through a normal map node. Very important. Drop that in there and in there. And then make sure you set this to non-color data so that it's actually correct. And I have not UV unwrapped my sphere, which is important whenever you're using an image texture. So I will just go U, sphere projection, extrude that out whenever I use the sphere, I don't know why, but it makes it really squished. So I just drag it out with S and then X to just scale along the X axis like that. And then let's have a look at it now. We should see it appearing on the actual mesh now. There we go. So we got some scratches. So far, so good. And the other one you can do is add some roughness to it through some wiping residue. So every material, if it's a household material, it's been cleaned. If it's an outdoor structure that can't be cleaned by hand, then it would be it could have stains on it from rain and things like that. We've got other ones on Polygon for that. But just imagine this is like a gold brick, say an old used gold brick. So it's got some smudges on it from handprint as well as wiping and things like that. So I'm going to add in 2 image textures that can do that. So the first one, let's just drag this in here. This one is going to be our wiping residue. So these are just some handmade like to imitate like if you're wiping off a desk. So it's that sort of look. So if I take this, set this to non-color, which you need to do whenever you're using something that's not influencing the color of the material, you set it to non-color, then feed that into the roughness input. And very subtle. In fact, actually, I'm not sure if this is the best, like seeing it on a sphere. Let's just try it with a plane. Unwrap the plane, and then I'll just use that same material on it. And hopefully, ugh, my goodness, what are we looking at? Ah, it's too bright. Maybe that's it. We're just looking at it and it's too bright. Okay, there we go. So now we can sort of see a little bit. Okay, you kind of have to have some darkness in the environment map to see the scratches and things like that, or else they all start to disappear. But anyways, okay, so I've got the scratches, I've got the smudges. So this is what it looks like before, and this is what it should look like with the smudge effect. If you can't see, okay, this is just the smudges by themselves. If you want to increase that, you could add a color ramp node and just turn down the effect there. So now those smudges sort of come through a little bit better. The other one I like to use is the fingerprint map. So these are some maps that we created just to imitate, because you want it to, like the whole point of it is to try and make it look like a real material. And no material is like any material that you can pick up is without fingerprints. Just fingerprints are everywhere. So we've got these fingerprint textures here. If I just drag that in there, you can see how that looks there as well. Now, normally you would layer them in, you know, different tiles and different things like that. But this is, I don't know, let's just say this is one part of a large material, and that's where people are touching it. So if I want to combine that with our smudging texture to influence our roughness, I just put them in a mix RGB node, drop them together, and set this to screen. So now we've got both of them in the same thing right there. And then I'll put this with our normal map, and there we go. So this is sort of how you create proper looking metal. So it's not going and finding a real metal material, which of course it doesn't work because there's no diffuse color for a metal object. There's no reason that there could be. So you can't really photograph metal. All you're really photographing is the reflections of the metal and any smudges or dirt on top of it. So anyway, this is how you actually go about creating a real looking metal material. Now, there's one final thing I want to show you, and that is to combine this metal shader that we've just created with the dielectric shader. Now, the reasons for doing this, I mean, there's two reasons you might want to do this. One is just to save time. So instead of having to remember like, oh, what am I creating? I'm creating a dielectric, or am I making a metal? You can just have one shader. By the way, this is if when you combine these two together, it's often called an uber shader because it's just, you can make a variety of materials from the one node group. But the other reason is for creating an asset for a game. What do you call it? It's called the metalness workflow. It's explained a lot on this site here. Really cool site, by the way. artisaverb.info/pbt.html. That's not a neat link, but anyways. And it explains how it works. Basically, it's what a lot of game developers use because normally you have the diffuse map, you've got a specular map, you've got a roughness map, and you've got a normal map. But game artists, they've often, instead of having separate models for like, okay, this is the belt buckle, so this is metal, and then this is a separate object for the belt, which is dielectric, they have to combine it into one model. So they don't just have a clear distinction between this object is metal, this object is dielectric. They have to be combined. So what this does is they create a metalness map. So it actually tells the software which parts of it are metal with a white color, and then which parts are dielectric with a black color. So he's using the example here of this handgun, which has a wooden base there. I did a rendering in Blender just to check that my thing works. And that's basically how this is working. So anyways, we're going to create an uber shader by combining these two together so that it will also work with the metalness workflow if you were into that thing. So how we're going to do this is by adding a mix shader right here, dragging this in here, both connected, and then connect that like that. Now, if you go all the way to 0, it's going to be 100% dielectric. If you go all the way to 1, it's going to be 100% metal. Some people say that it should be one or the other. It should never be a variation of it. And then other people say, you know, that's crap. You know, of course it can be a variation of it because metal is never 100% metal. What I mentioned before about the line between the two of them. Anyways, we're just going to use that combined together. And then I'm going to combine these node groups together by hitting Control G. So that's the cool thing about node groups is it's like Inception. You can go deeper and deeper with the layers. It's a little confusing sometimes. Anyways, what I'm going to do is I'm going to make it so that we use the same base color for the dielectric as we do for the metal. So we're just sharing the same one there. I'm also going to share the same one for the roughness, like that. The reflection, however, actually, no, we'll leave that reflection just as it is. But the one that we do want to have exposed to this is this mix shader. So I'm just going to take that factor input, put that down there. And then this factor value on the outside here is just going to allow us to control between the two of them like that. So then we could name this, if we wanted to, we could name this the dielectric / metal. And then you know, if it's all the way 0, it's dielectric. If it's all the way 1, it's metal. And there you go. So that's just, you know, it's because metal behaves so differently to dielectrics that you kind of have to split them up like that. And that's why a lot of games use the metalness workflow. That's how it works with Substance Painter a lot. You know, although you can export different types of maps. I'm getting into too much technical stuff. Now, to show you that it works, I'm just going to quickly open up a pre-prepared file which has the gun in it already, just to show you that it actually does work. So this is the gun. And you can see that it's got this same node setup that I've just got there. I called it the PBR Uber, by the way, which is what it's often called. It's a Uber shader. And you can see that it's working fine there. So it's making the wood show through as a dielectric and the rest of it is showing up as metal. And it works quite well. And I also used it on this, which I exported from Substance Painter just to see if this would work as well. And it's just adding in the different ones right there. But anyways, that basically concludes this tutorial. Now, some people in the comments on the last one, they were curious about what about materials like skin, glass, and other things like that. Like, how does that fit into the dielectric / metal workflow? Personally, myself, I just go and I just use the glass shader right here, if it's a liquid or if it's a glass, because I haven't found, because the problem is that once you increase roughness on glass, it should behave a little bit like this. But I've found that when you try to use like the Uber thing here, like the, what do you call it? What am I talking about? The reflection, like this reflection node here, and then you put it into a transparent node like this. What ends up happening is that as roughness goes up, you end up getting a darker and darker looking glass, which doesn't look quite right to me. Whereas real glass should be a little bit brighter like that. So I just haven't found there to be much. And I've heard that the glass should be fairly PBR accurate. I don't know. You guys can discuss it in the comments if you were interested in glass in particular. But I personally just use the glass shader because I find that it's good enough. And then you can also, so this reflection shader here, the reason we made this a separate thing is so that you can feed anything you want into this shader here. So if you are making skin, for example, you could use the subsurface scattering shader like this. Maybe turn the roughness down to something a little bit more appropriate. You could use this and maybe set it to skin and then give it whatever. But you can see it's got the reflection on top of it, and that'll be accurate. Like most, like skin should be. So it's got reflection on the edge of the thing because it's powered by the Fresnel going into here. And that's pretty, and then like you also, like if you're making a more advanced, like this is, again, it's for like 90% of materials, but if you wanted a PBR metallic shader that also had the anisotropic, like if you're making like a fry pan and it's got that radial or like a brushed metal sort of material, you would just use that same metallic shader here. Whoa, where is it? Hang on a second. You would use the same metallic shader here, but instead of this right here, all you would do is you would replace it with a anisotropic shader right there, because that's basically what it is. It's just going through there. But anyway, so this Uber node here will get you through most materials, the dielectric, the metals. But you just have to play around. And I know that's not, you know, for any beginners out there, it's probably pretty daunting to have to think about what sort of material you're going to make. But don't overthink it, you know, just use the dielectric when you can, use the metal when you can. And if you need to tweak it a little bit, don't be afraid to tweak it. The idea, as I mentioned, is that you're supposed to be using this stuff to sort of get you like the first step in the right direction. You don't have to think about it. You don't have to be worried about time constraints and setting up the power node and the reflection and the Fresnel, making sure that that's all accurate every time you do a material, because you never will. It's supposed to just save you time, get you there, and then if you want to tweak it in the future, you can. You don't, like, this is where the artist has freedom to control things. So yeah, you can use it with a translucency node or whatever. So just play around with it, have fun with it. And by the way, if you want my node groups that I've created here, I'm going to put it into one little nice, neat blend file. It'll have the Uber shader, it'll have the metallic, the dielectric, as well as, you know, the reflection, Fresnel node, and my, what's it called? More, less slider, and the metal colors as well. So if you want to go and just download it, maybe you didn't follow along with this tutorial, but you understand it, save yourself some time and just download it and just make use of them. They're CC0, so you don't even have to give credit. You can just use them. It's my little gift to you. So anyways, that's it, guys. Thank you for watching. And if you do make something cool, please do post it on Blender Guru. So click this link here, which is also where you can download the blend file. Click the link there, go to the comments and post in whatever it is that you make. Very interested in seeing all the stuff you guys create. Anyways, that's it from me. Thank you for watching. I'll see you next time.